Okay, everyone, problem number 2 from the assignment. Hopefully this was pretty straightforward. Had a little binomial stuff as well as normal stuff, so a little good combination of things here. This problem says a tire manufacturer designed a new trad has a normal distribution, mean of 125, standard deviation of 6.5. The fact that it's normal is pretty important in everything we're about to do. Remember, anytime you hit that inverse norm button or normal CDF, you got to check for normal. First question is, what's the 70th percentile? So 70th percentile is here. I need that z-score. So the original way we did this was just to find the z-scores. But now we have the inverse norm button, right? So the inverse norm finds the z-score, which you could find, and then use the z-score formula to solve it. But inverse norm 0.7 with a mean of 125 and a standard deviation of 6.5. Give me 128.4. I think that's feet. Should probably have some units on that. Part 1, if you're grading, EPI. Second question says, what's the probability at least 2 out of 5 cars will stop at a distance that's greater than that? So the probability that any one car stops greater than that is 0.3. So that's kind of like your probability of success is 0.3. So there's 2 ways to do this problem. One is to list out all the possibilities. I didn't really do that here. I just started it. 0 successes, 5 choose 0, 0.3 is the success rate. I'm going to stop greater than that distance to the 0.7 to the 5th. If you wanted any of the other ones, you could do the same thing. And then we want at least 2. So we would add up all those, which means really I just have to find this one and this one and subtract from 1. The other way is the binomial CDF button does the same thing. Remember, the binomial CDF button will add up from 0 to whatever you want it to add up to. So for this particular problem, binomial CDF, number of trials is 5 cars. Probability of success is 0.3. And it can't add up these, so I need it to add up 0 and 1, so that's the number that I put in there. So the 1 is telling me it's going to add up from 0 to 1. If I put in 4 there, it would add up 0, 1, 2, 3, 4, and so on. So that's 52.82%, but that's those two, so I want to subtract that from 1. And answer 47.2% for that one. And then, that part, B, was also an EPI, so that was the second part. And third part is a sampling distribution problem. It said, what's the probability that a randomly selected sample of 5 cars will have a mean stopping distance of greater than 130 feet? So this is my population. Remember, normal population, mean of 125, standard deviation of 6.5. The sampling distribution for a sample of size 5 is going to have the same mean as the population. And the standard deviation is going to be 6.5, the standard deviation population divided by the square root of n. Sample size is not big enough. It needs to be 30. However, since the population is roughly normal, I'm totally okay. If they had not told me the population was roughly normal, I would need to have a sample size of at least 30 or I wouldn't be able to do it. And now it's just a normal CDF problem. Normal CDF from 130 to infinity with a mean of 125, standard deviation of 6.5 over root 5, 4.27%. This is the third part of that problem, so the third EPI. Again, if you don't know what that means, go check out my little video on the FRQ grading and that will help you with that. So that's it for problem number 2.